Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on Poisson distribution part 2. In the last session, we have introduced the Poisson distribution, then we have calculated the mean and variance of Poisson distribution, and the mean of Poisson distribution is mu equal to lambda, and variance of Poisson distribution is also sigma square is lambda. That means the mean and variance coincides for the Poisson distribution. Coming to today's presentation, today I would like to solve some problems on Poisson distribution. Now coming to the first problem, if the probability of an individual suffers from a bad reaction from a certain infection is 0.001. The probability of an individual suffers from a bad reaction from a certain infection is 0.001. Then determine the probability that out of 200 individuals, exactly 3, more than 2 and none suffer a bad reaction. So determine the probability that out of 2000 individuals, exactly 3, more than 2 and none suffer a bad reaction. So here, first point is when we have to apply Poisson distribution. The Poisson distribution is applied when n is very large and p is very small. That means if the number of trials is very large and probability of success is very small. Here given out of 2000 individuals we need to test. So n equal to 2000, a big number. That's why we can apply the Poisson distribution. Not only that, the probability is also given, small p is 0.001. So here n is very large and the probability p is very small. Therefore, we apply the Poisson distribution. Now, what is the formula in Poisson distribution? By the Poisson distribution, the probability of x successes is given by e power minus lambda power x by x factorial. So here lambda is the main value. Lambda is called the parameter of the Poisson distribution. So first we need to calculate this lambda. If we have the value of lambda, we can calculate any probability of any successes, for example 0, 1, 2, 3 and so on. Since the formula contains only the value of lambda, if we have lambda, we can calculate any probability. Now how to find that lambda? That lambda is not given in the problem. So we have mean of binomial distribution. Mean of binomial distribution is mu equal to np. Similarly, the mean of Poisson distribution is mu equal to lambda. So this lambda is the mean of Poisson distribution. So here we need that lambda. If for example, if we are applying binomial distribution, already we have these two n and p values are given. But since n is very large, to calculate the NCR value, it may be complicated or time taking. That's why we apply Poisson distribution. In Poisson distribution, the mean is mu equal to lambda. But the Poisson distribution can be approximated by binomial distribution by taking lambda equal to np. So using this, lambda value can be obtained 2000 multiplied by 0.1. So lambda value is 2000 times 0.1 and the answer is lambda equal to 2. So therefore, we have lambda equal to 2. Now the first question, we need to find the probability of exactly 3 individuals suffer from the bad reaction. So probability of x equal to 3 we need to calculate. So probability of x equal to 3 can be calculated using the formula e power minus lambda power x by x factorial. So here lambda is lambda is 2. So e power minus 2 power x by x factorial, and that x is given here 3. So 2 cube by 3 factorial. So we can calculate this value of e power minus 2 using a calculator, and 2 cube is 8 by 6. So this is 4 by 3 times of e power minus 2. And the final answer is given by 0.1804. So the probability of 3 individuals suffer from bad reaction is 0.1804. Now coming to the second problem, more than 2. So more than 2 means we need to calculate probability of x greater than 2, which can be obtained using 1 minus probability of x less than or equal to 2. So 1 minus probability of x less than or equal to 2 means less than or equal to 2. So x equal to 0, probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So which is 1 minus e power minus 2, that is lambda value is 2. So e power minus 2, 2 power 0 by 0 factorial plus e power minus 2 into 2 power 1 by 1 factorial plus e power minus 2 2 square by 2 factorial. So this is the probability of 0 successes, and this is 1 success and 2 successes. Here e power minus 2 is the common value. So 1 plus 2 plus this 4 by 2 is again 2. So 1 minus e power minus 2 into 5. So using a calculator you can find this value of e power minus 2, and the final answer is equal to 0.3233. And the third question, none suffer a bad reaction. None suffer means the third one is nobody should suffer a bad reaction from that medicine. So x equal to 0, which is e power minus lambda power x is 0 by 0 factorial. So the answer is simply e power minus 2, and the value of e power minus 2 is 0.1353. So like this, if we have the value of lambda, which is the parameter of Poisson distribution, we can calculate any given probability. So here in the first question, probability of 3 individuals suffer bad reaction, and in second problem more than 2 individuals suffer bad reaction, and the third problem no one suffer from the bad reaction. These values are calculated using the value of lambda equal to 2 in Poisson formula. Coming to the second problem, here the given information is a hospital switchboard receives an average of 4 calls in a 10-minute interval. The hospital receives average 4 calls per 10 minutes. What is the probability that there are at most 2 emergency calls and exactly 3 emergency calls? So here in the first problem at most, and then the second problem exactly. Exactly means simply we can say at x equal to 3. But now there are 2 things, at least and at most. At least means that number is the minimum number. At most means that number is the maximum one. So here first write the given data. Given that average of 4 calls. So the mean number of calls is given 4 in a 10-minute interval. Now what is the probability that there are at most 2 emergency calls and exactly 3 emergency calls? For example, if we want to apply binomial distribution, we must have n, the number of trials, p, the probability of success, and then we using p we can calculate q, and we use the binomial distribution. So we need to find so many values. Whereas here in Poisson distribution, if we have the value of lambda, that is enough. If we have the value of lambda, we can calculate the probability of x equal to some xi. So here we know that the mean of Poisson distribution, is mu equal to lambda. So here this is the given mean mu. So lambda value is given in the problem. So no need to find n, p and other values. So directly lambda is given. Now by Poisson distribution, probability of x successes is given by e power minus lambda power x by x factorial. Now in the first question we need to calculate the probability of at most 2 emergency calls. So first question, probability of at most, just now we have discussed at least means that number is the minimum, at most is that number is the maximum. So here at most 2 emergency calls means x greater than x is less than or equal to 2. That means that 2 is the maximum value, x less than or equal to 2. So which is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So the sum of these 3, and we have probability of x successes is e power minus lambda is for lambda power x by x factorial. Let us use this formula here to find this. So e power minus 4 power 0 by 0 factorial, the same we follow for all the 3 values. E power minus 4 square by 2 factorial. So e power minus 4 is common. Here this is 1 plus 4 plus this is 16 by 2, 8. So 13 e power minus 4. And this value is equal to 0.2381. So we can find this e power minus 4 using a calculator. Now coming to the second problem, the second one, exactly 3 emergency calls. So probability of x equal to 3. So e power minus 4, lambda power x means 4 power 3 by x factorial 3 factorial. So which is equal to e power minus 4, 64 by 6. So e power minus 4, 32 by 3. And using calculator we can find the final answer as 0.1954. So the first one is the probability of at most 2 calls in a 10-minute period, and second one probability of exactly 3 calls in a 10-minute period. These 2 values are calculated using the Poisson distribution. Similarly, let us discuss one more problem. The third one, a manufacturer knows that the condensers he make contain on an average 1% defectives. So that means what is the given data? Given the probability of defective items or condensers, defective items is 1%. So that means 0.01. The probability is very low. And then he packs them in boxes of 100. What is the probability that a box picked at random will contain 3 or more faulty condensers? So the manufacturer packs the condensers in a box having 100 condensers, and it is required to find the probability of 3 or more faulty condensers in a selected box. So that means in a box there are 100 condensers and we need to check one by one all 100 condensers. So here the number of trials n equal to 100, and this is the probability of a defective item given by 0.01. So we know that in Poisson distribution this lambda is given by NP. So 100 into 0.01. So therefore the lambda value is equal to 1. Hence the mean, that is the lambda, is equal to 1 in the given problem. Now we need to calculate for a selected box what is the probability of there are 3 or more faulty condensers. So it is required to find the probability of x greater than or equal to 3, and we know that in a box there are 100 condensers. So to calculate this probability of x greater than or equal to 3, in fact we need to start from x equal to 4, x equal to 5, x equal to 6 and so on up to 100. But instead of finding these many probabilities, we can use the property that probability of success plus probability of failure is equal to 1, or probability of occurrence plus non-occurrence is equal to 1, or the total probability is always unity. So using that probability, probability of x greater than or equal to 3 is 1 minus probability of x less than 3. Here already equality is there, that's why we are using strictly less than here. Now, so probability of x greater than or equal to 3 is 1 minus probability of x less than 3. Less than 3 means how many values are there? Probability of x equal to 0, x equal to 1, x equal to 2, since it is strictly less than 3. Now, by the Poisson distribution, probability of x successes is given by e power minus lambda, lambda power x by x factorial, and here lambda is calculated as 1, lambda equal to 1. So, after using the formula here, e power minus lambda, lambda power 0 by 0 factorial plus e power minus lambda, lambda power 1 by 1 factorial plus e power minus lambda, lambda square by 2 factorial. So, after substituting all these values and calculating the total answer here, we get 0.9197, which is equal to 0.0803. So, this is the probability of a box having more than 3 or more than 3 defective condensers, a very, very low probability. Coming to the summary, in today's session, we have discussed some problems on Poisson distribution. So, in Poisson distribution, the probability is calculated using the formula e power minus lambda, lambda power x by x factorial, and sometimes in some problems, the number of trials n and probability of success p will be given. So, using these two, we can calculate the value of lambda as np, and in Poisson distribution, the parameter is lambda. In Poisson distribution, the parameter is lambda, which is the mean and variance of the distribution. In the next session, we will discuss some more problems on Poisson distribution, and then we fit a Poisson distribution for the given frequency distribution table. Thank you. We will meet in the next session.